Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we will be solving a problem actually that's requested by one of the students. So the first part of the problem, okay, is to express the force F2 and F1 in Cartesian vector. Cartesian vector obviously referring to I, J, K, okay, in that form. So that's the first question. I think they meant F3. Okay, sorry, this is F3 by the way. I can't see because the right question is a little bit unclear. But anyway, let's express it first. So let's do part A. So to express in terms of ijk vector, okay, it's pretty straightforward. So F2, okay, we start with F2 first, okay. Alright, don't forget to put the arrow. So F2 is, in terms of I, it is 26 12 over 13 I, okay, make sure it's negative because it's going to the, you can see it's going to the negative direction of x, right? So don't forget about that. Okay, also followed by plus 26 times 5 over 13 j. Okay, so that's for F2. And we don't have K because the thing is that this is only in terms of X and Y. So it's only in terms of two directions. So therefore, if I were to simplify this vector, let me just take my calculator and simplify real quick. 26, 12 over 13. Okay, so it's just negative 24I plus 10J. Okay. Alright, so that's for F2. Now for F3, okay, similarly for F3, alright. So for F3, we can see that if we resolve the vector itself into its x and to its y components, is the x is the y. The x is clearly positive, the y is clearly negative. So in this case, when we try to resolve it, so in terms of x is 36 cos 30 I minus 36 sine 30 j. Right, so once you simplify with the calculator, 36 cos 30, or this, let me just convert the angle first real quick. Cos 30. Okay, so we get 18 root 3 I minus, let's see, sine 30, minus 18j. Okay. Oh, by the way, don't forget to put the units here. I almost forgot to put the units, by the way, because it's a force, so don't forget that we also have the units as well. And I know the question just asked for F2 and F3, but if let's say they also wanted to find F1, yeah, just out of curiosity, by the way, even though I don't think they're asking for F1, but anyway, let's just find F1. So if F1, it's pretty straightforward because we know that F1, when you resolve into its components, it's going to be in the positive x direction and it's going to be in the positive y direction. Therefore, it's just going to be F1 cos theta I plus F1 sine theta j. Okay, so that's for F1, just in case if it's needed. Make sure don't forget the units, yeah, kilonewton, because we're dealing with force here, so we have to make sure in kilonewton. So that's the Cartesian vector. Okay, we want it in ijk, or sometimes if you also want to express it like this, like maybe in terms of x, y, z, also can for Cartesian vector, right? Or also you want to express it like this, x, y, z. So I think any of these expressions are fine, whether you want to express in terms of ijk or this, but preferably we stick to ijk lah, because I think that's usually the common standard, but any of the other two also is considered fine. Okay, so now we go to part B. Part B says if the magnitude of the resultant force is 20 kilonewton and directed in the positive y direction, what is the magnitude of the force F1? Is direction and theta measured counterclockwise from the positive x-axis, meaning theta measured from here. Okay, 10 marks. Okay, so it's actually pretty straightforward. Let me just rotate this page real quick, by the way. Yeah, okay, better. Okay, so if you can follow, we already know f2, and we already know for f3, we already know f2, we already know f3, but f1 we don't know. But what we do know is that the magnitude for f1 is 20 kilonewton, right? No, sorry, not 20 kilonewton. Magnitude of the resultant, my bad. The resultant we know, okay, is just 20 kilonewton, and we know the direction is clearly where? Positive y-axis. Y-axis positive. Okay, so that is to say that the summation of fy, okay, is just 20 j kilonewton, and the summation of fx, okay, is 0 I kilonewton. Okay, so that, because the resultant we've already mentioned, this is the magnitude of the resultant itself. This is actually the magnitude, by the way, not the vector, right? It's the magnitude. Okay, and direction y-axis positive. So in this case, what we're gonna do is, of course, we'll take the y component of all the vectors right here. So for f2, f3, and this one f1, right? And we'll try to solve it. Okay, so we have here 10j plus f1 sine theta minus 18j, sorry, f1 sine theta j minus 18j. Okay, make sure you put the arrows here, by the way. I forgot to put the notations. Okay, because we're dealing with vectors, by the way. Okay, minus equals to 20j. Okay, so right, so of course you can eliminate the j actually, by the way, because the j is just only there to show it's in the j component. So it would just simply become f1 sine theta would be equivalent to what? Would be 20 plus 18 minus 10. How much is it? So f1 sine theta is equal to 20 plus 18 minus 10. This is going to be 28. So f1 sine theta is 28, of course, kilonewton, because it's the magnitude, right, of the force. Now we're going to, of course, solve for the fx. So we take the x component I'm highlighting in blue. So here, here, and here. So negative 24i plus f1 cos theta I, right? And I think it's a minus or a plus. Okay, plus is 18 square root 3 I equals to 0i. And again, you can take out the I, obviously, because it's just a vector only, right? And then you're left to it. f1 cos theta is equal to 18 root 3 plus 24. So you see that we actually end up having two equations, by the way. So we obviously end up having two simultaneous equations, right? Which I'm going to mark in purple, by the way. So it's going to be 1 and it's going to be 2. Okay, and you can see that the reason why we have a simultaneous equation is because there are two unknowns. We have the f1 and we have the theta, right? So that's why you obviously need two equations to find two unknowns. Okay, I think some problem right here, but no worries. Okay, so I think we can rearrange it. So we can say f1 equals to 28 divided by sine theta. This is then we can call this equation 3, no problem. Okay, so rearrangement anyway. Then we substitute equation 3 in 2. So therefore f1 becomes 28 over sine theta times cos theta equals to 18 root 3 plus 24. So we know that cos over sine theta becomes 1 over tan theta, or cot theta. Okay, so cot theta equals to 18 root 3 plus 24. and cot theta is equivalent to 18 root 3 plus 24 over 28. And since cot theta we know is obviously 1 over tan theta, right, which is obviously cos theta over sine theta, right? So I'm gonna rotate this page real quick counterclockwise. Okay, let's make it nicer. Okay, so yeah, so 1 over tan theta is equals to 18 root 3 over 24. 18 root 3 plus 24, no, over, my bad, over 28. Then therefore tan theta is just the opposite, it's just 28 over 18 root 3 plus 24. Okay, then theta, obviously you do the tan inverse, you should get 28 over 18 root 3 plus 24. How much is it? So you get 26.906. So 26.906. I know in 3 decimal place, but usually for angle we write in 26.9 degrees. And I believe that's what they're asking for. They're also asking for theta as well, right? So your theta is 26.9 degrees. Then for your force F1, so we can say substitute theta in equation 3, so in equation 3, so therefore your magnitude for F1 is just 28 over sine 26.906 degrees. So 28 over sine of this, how much do we get? So 61.875 kilonewton, which is just 61.9 kilonewton. Okay, 61.9 kilonewton, because this is the magnitude they wanted. This is the answer they wanted, by the way. Now, one thing we can do is to check if we can show that the values of F1 and theta, it's correct or not. How can we verify it? Of course, we check back with this equation right here. We check back with this equation right here. So, okay, there's some glitch here probably, I don't know why. So we check back with these two equations. So the first equation, we have to show that it's just 10j plus this one minus this one is 20j. So we can do a verification check. So this is for a verification, by the way. This is not really like to it's not really important, but it's very good to verify, just to check. You can do it mentally also, physically no problem, but I'm just going to do it real quick just to prove. So verification, what is it? I'll just take this equation right here. Actually, let me snapshot this equation real quick. Copy. Okay, right. So if you want to erase this, erase the j also can. This was 10j, right? 10j. This was positive. This was, I believe, negative, right? Let me just double check. Yeah, positive, negative. So we know that it's just 10j plus 61.875 sine 26.906. Okay, 26.906 minus 18. Sorry, this is supposed to be j, by the way. J minus 18j. So it becomes 10j plus 61.875 sine 26.906. So it becomes 28.0001 or 0002 actually, j minus 18j. So it proves to us that, so 10 minus 18 plus 28.0002. Okay, so it's about 20.0002j. Okay, So which is obviously equal to 20j, right, in the y-axis. Okay, and then for the x-axis you can also check as well. I'm just gonna copy the equation real quick just to verify, by the way. And this is not an important step actually. You don't have to do this. You don't have to show this to your lecturer or whatnot for the midterm. No need to worry about this. But the idea of verifying is just to make sure that your answers are right. So in this case we got negative 24i, okay, plus 61.875 cos 26.906 r plus 18 root 3 r, okay, equals how much? So it becomes negative 24r plus 61.875 cosine 26.906. So it becomes 55.177r plus 18 root 3r. Okay, so after you compute all of this, you won't get exactly 0, by the way, but you'll get a number very close to 0 supposedly. Wait, hold up. 5 cosine 26.906 minus 24. Wait, let me just double check here. Let me see if it's right or not. Okay. So you see, I made a small sign mistake here actually, because when I moved it here, it's supposed to be negative, by the way. So yeah, there was a mistake in my calculation. Okay, and yeah, you should have negative. So negative, yeah, so it should be negative here. If you're following the negative sign, so your tangent would become tan inverse 28 over negative 18 root 3. Okay, or you could just say 24 minus 18 root 3. What should that become? Okay, so they put negative 75.624 624 degrees. Okay, now negative, what does the negative actually mean? The negative actually means that from the x-axis, this angle was measured in the other side. This angle was measured in the other direction. So we want the positive one, right? So it's not measured counterclockwise. It's actually measured clockwise from the positive x-axis. So negative, I think, in this case 90. So 90 minus 75.624 be this one. So the correct way actually is that if you have a force here in x-axis, and this is your F1, right? And when they say negative, that means it's measured from clockwise actually. So 75.624 degrees. So you want to find this angle theta. It's obviously gonna be 90 minus 75.624 degrees. So your final answer should be 90 minus 75.624 should be 14.376 degrees, or it should be about 14.4 degrees. Yeah. Okay, then therefore your answer would be 14.376, right? Your force also be different as well. So sine 14.376, how much would that be, huh? So 112.77, yeah, so it becomes 113 kilonewtons. Okay, so let's just try it out. Let's just see first if we get the same answer or not. So it'll become 112.77, so it's a 112.77 sine 14.376. How much is it? Let me see. 112.77 sine 14.376. Okay. So this one is very close to 20 actually also. This one is like about 27.999 J. Okay. So this is very important. That's why I say verification is also an important step. If you actually just compute on the calculator, then you can also see if you're right or wrong, if your angles are right or wrong. In my case, it was wrong. So that's why I had to, do the verification actually. Okay, so you see this is okay, this is alright, so this is fine. Now this one we check. So this one's supposed to be 112.77 cosine 14.376 degrees I. So it should be 112.77 cosine 14.376. How much is it gonna be? 109.24 I. Negative 24 plus 18 root 3. Wait, something is not right here actually. Let me see, why is it not correct? Okay, so f1 cosine I be positive, f2 become negative x, and f3 become positive x. So 36 cos 30 should be positive, right? 18 root 3, 36 cos 30. 18 root 3. So 18 root 3, sorry, 18 root 3 has to be positive, okay. And 24 is negative, yeah, so 24 is negative. And this one must be 0. Okay, this whole thing must be 0 actually. Okay, so because I moved to the other side, the signs have changed. Okay. So this one, negative angle. Let me see from the quadrants first here. It's all positive, right? Sine positive, 90 to 180. Okay, then here's 270. So this one I think sine, cosine, only cosine positive and tan positive I believe, right? Yeah, because this is tan negative. So this is cosine positive, and this one should be tan positive I believe. Yeah, okay. Yes, okay. So if tan negative, negative 77, so this one is 75.264. So this one should be how much then? Okay, so this one obviously has to be so this one angle I think should be 194.376 degrees. Let me just check first. So tan 194.376, 0.246. Okay, so tan 194.376 should be 0.246. 0.256. And then theta is how much? 28 over 24 minus 18 root 3. Okay. Okay. Okay, so root 3. So it will be negative 17.5. So negative means that the angle is definitely in the opposite direction. Okay. Now if I did tan over this angle, 0.256 by 28 over 24 minus 18 root 3. Tan theta is negative 3.901. Okay. So you have a little bit of a dilemma actually with the angle, to be honest, because the angle can be a little bit tricky. So I know that tan, if we use it's negative 75.624, then we get close to 3.901. But our question wanted to find theta measured counterclockwise from the positive x-axis. So what is the theta actually? Because this theta itself, this one is not really acceptable. So we need to find what is the theta in the positive x-axis. So in this case, okay, let's see, what am I doing here wrong? No, we need this answer specifically. Point 64 104 6 degrees. Okay, let me see. So if we were to figure out, let's say for example, so okay, if we use the quadrant, okay, got it. So in order to actually find theta, by the way, since we know that our theta is negative, right? So what does it mean? It means that from the x-axis to the y-axis, right, we're supposed to find theta with respect to clockwise, counterclockwise, meaning from here. Okay, but our theta is negative, meaning to say that it comes clockwise. Okay, it comes clockwise from the x-axis. So that's what they're trying to say. That means our actual f1 is here. Okay, so since our actual f1 is here, so that means that this is our theta right now, the negative 75.624. But we are interested in from the positive x-axis. So how do we find that? We find that obviously by 180 minus that 75.624. Okay, it's not minus actually, but you just add the negative sign now. So it becomes 180, add the 75.624 degrees. Then you will get 180 minus 75.624. It should be 104.376 degrees. 104.376 degrees. Okay, let me make this a little bit clear. Okay. Okay, let me draw a clearer diagram because yeah, it'll be easier that way. Okay, so this is our x, that's our y. Okay, so currently what happened is that our f1, oh shoot, sorry. Okay, then come back. Okay, never mind. Our f1 is like this. Okay, our f1 is here, and this is the angle that we found earlier, which was 75.624 degrees. The whole idea of this negative sign actually is to show that it's going clockwise. It's going clockwise from x-axis. Okay, but our theta is counterclockwise. Our theta actually is counterclockwise. Okay, so that's why I actually had to subtract 180 with this one, because this entire line obviously we know is 180. To get 104.376, or in one decimal place we'll write it as 104.4 degrees. Okay, so 104.4 degrees. Then from there, of course, you do the rest of the steps. It should be pretty straightforward, right? It's 28 over sine 104.376. So the force should be 28.905 kilonewton. It's just 28.9 kilonewton. Okay, then as usual you substitute everything, so it becomes 28.905 sine whatever this angle is. It's supposed to be 104.4 0.4 or 376. If you have space you can write 376. So 10 plus 28.905 sine 104.4 minus 18. Okay, so all in all, okay, if you were to compute it, you would get about 19.997 J, which obviously is very close to our 20 J kilonewton, right? So this is what the idea behind it. Okay, and then for this one, for x, right, we're interested in x. Let me just label this as fy, okay, just to make it easier, and fx. Okay, so of course 28.905, right, cosine 104.4 I, and this one, right, okay, minus plus 80.4 J. Okay, 28.905 cos 104.4, so it's negative 7.188 I. Okay, and once you compute it, minus 7.188 plus 18 root 3, okay, you get negative 0.0011 I kilonewton, which is very small, by the way. You can consider it to be 0 I kilonewton. Okay, so you see, after verification we have managed to verify it already, right? We managed to verify our answers actually. So this is why it's very essential that we should verify our answers. Okay, so that means that our answers are, we can consider it to be correct actually. So f1 should be this one, our theta should be this one. Okay, this one is obviously counterclockwise to the x-axis, remember that, yeah, because we already explained that earlier. So this is very essential that we should verify our answers. Okay, because when we verify our answers actually, we're very sure that we get the correct that means our values for f1 and for theta are correct. Okay, so with that being said, hopefully this video was helpful, and hopefully you know, it helped you to tackle such problems in the midterm. Any other questions, please let me know.